Welcome, fellow knowledge seekers, and welcome to today's presentation about linear regression. And now that the funny voice is out of the way, welcome everyone to my presentation today. Today we're going to be going over simple regression, multiple linear regression, and some just tips I have found along the way that have kind of helped me out and maybe help you all out too. And as always, if something I have said is confusing to you or you think I'm not right, which could be the case, then comment below in the discussion on my thing and help me clear it up. So on to what is regression analysis. So regression analysis is really just, the basic principle is it's a line that's helping to predict the strength of your model. And trying to use it for predicting a data set. Now, it's not always going to be necessarily the best line for prediction, but it is the one that's going to explain the most what outcome you're trying to get for your data. It may only explain like 95% of it. It may not explain 100% or 85%, but it is the best line and best prediction you can get for your outcome. So again, regression analysis in general is used to explain, or more commonly referred to, predict the outcome variable. The outcome variable may also be considered your dependent variable, but for the sake of not trying to confuse people from previous sections we've had, I'm just going to refer to as the dependent as the outcome variable. And as always, with any type of testing we're doing, but especially with regression analysis, always remember to test your assumptions. There are a few different additional assumptions that we will talk about later that deal more with just regression, but as always, run your normal assumptions that you would any other testing. So on to simple linear regression. So this is where we're going to start out first. And I'm sorry for the dogs in the background. So simple linear regression is simply looking at a one-to-one relationship. So you're looking at an independent variable, but for the sake of this presentation, which we're going to call the predictor variable. So this is what the researcher is trying to predict for the outcome. The different variable he's trying to look at, will that predict my outcome? And then it's also looking at a outcome variable / dependent variable. And this is what the researcher is trying to predict. So for example, you've got a variable over here, so you're trying to explain why people gain weight. Well, you've got over here sedentary activity, you've got high fat foods, you've got genetics, so on and so forth. All those, the genetics, high fat food, and sedentary activity, those would be your predictor variables, or the outcome variable is gaining weight. So simple linear regression uses the line that we talked about earlier, the linear line, but that is called the best fit line. It's called the best fit line because it is the best line that you can come up with. It's not going to be 100% always on the time, but it is going to be the best line that fits your data for your predictability. Usually you'll find the best fit line through the least squares of sum or the squares of residuals. And again, we'll talk about that a little bit later, but that's just two different ways. When you look at your linear line, you're looking at where your data points fall on your graph and seeing how far they are from that line. And you add those residuals up from those data points, and that gets you your square residuals. So generally, to look for your best fit line, you're going to look at your scatter plot, which is going to be more of something that you're just going to look at. You're going to obviously run that through SPSS, but that'll be something where you'll look at your I, does it actually have a linear thing? But you're also going to look at your R value as well on your graph. And then you can see here in this example that this would be like a linear relationship. And you can see that all the data points don't necessarily fall on that line, but they are very close. And you can see that that they go from the bottom left-hand corner all the way up to the top right-hand corner. And like where those data points would fall, you can see some of them are higher and lower. The residual would be from that point to that line. How far are they from that point to that line? And that is the residual, and you'd add all those residuals up, or SPSS would add it up for you. And that's what you would get for your square of residuals. So after finding your best fit line and looking through the scatter plots and meeting your assumptions that way, you will test your model through it'll test your model through the ANOVA test, or the F test for when you're writing it out in your paper. The big thing with the ANOVA test is that, simply put, if it's not significant, again, over 0.05, then try again, go back. It's not significant, because that's just basically telling you that the variables that you have tried to use to predict your outcome are not good. They don't predict anything. So again, go try to find other variables, or maybe reword your question differently. So moving on to multiple regression. So multiple regression is simply an extension of simple, except now instead of a 1-to-1 ratio of predictability, you're using a 2-to-1 or a 3-to-1, 4-to-1, so on and so forth. So you're using multiple predictor variables to predict your outcome, one outcome variable. One of the problems that I have seen and other people have talked about with multiple regression is that there's a problem of overfitting. And what that means is, so you've got, again, in nature and most of the worlds, there's not going to be just one variable that explains a certain outcome. But what the problem is sometimes is when you run your test and run your variables, you've got so many predictor variables over here that it's actually crowding out what the real true value or what the real true predictability of your outcome variable is. And sometimes having all those variables will give you a really good result. But really what happens is that those predictor variables are giving you a false pretense. They're not actually explaining as much as you think they are. So that's a problem you got to watch out for. And again, you run your assumptions for each individual independent variable to dependent variable, and then 2 at a time, 2-to-1, 3-to-1, just to see if that is true, that they will predict what you're intending them to predict. So moving on to something that I saw that I thought kind of helped me out a little bit, just as kind of like a checklist, especially, and this would be for multiple regression, but in a way you could modify it a little bit for simple regression as well. But this is the list that I specifically found for multiple regression. So, and this is just for pre-work for multiple regression before you ever run your multiple regression test. So number one, make a list of predictor variables, predictor and outcome variables. This is basically just stating, what is your outcome variable, obviously, first, and then what are you trying to see what are you trying to use to predict that outcome? You don't want to just run in blindly when thinking, okay, this is what I want to do. Sit down, take your time as what you want to do. Your second would be collect data on the variables. Again, this seems kind of straightforward. You've got your variables, go out and get your data. Step 3 is check the relationships between IV, independent variables, and DV, dependent variables. Or again, independent predictor variables and outcome variable. You want to do this because, again, if you've got like 3 or 4 predictor variables, you want to see, again, if overfitting is the problem. So you want to, again, check each relationship to the outcome variable. So again, if you had, for example, 4 predictor variables, 1 outcome variable, you would go, 1-to-1 on each of them, and then you'd choose like 2-to-1, and then you work your way 3-to-1, and then you'd work your way 4-to-1, and you would see what your different values are, statistical values are for each of those, to see if they're actually predicting what you intend for them to predict. The 4th step is to check relationship among your predictor variables or independent variables. And what this is more referring to is the notion of multi-collinearity. What that is really just the relationship among independent variables. And again, we'll go on that a little bit later, but you want to test that because if your independent variables are very closely related, it will throw off your correlation or your regression as well. The fifth step is use non-redundant independent variable predictor variables to find the best fitting line. You don't want things that are redundant in your line because, again, they'll throw off your regression. And then finally, use a best fitting line. So I'm going to show you something here a little bit later that I found really useful, but you can make like a table of all of your outcome, your predictor to outcome variables and seeing which gives me my best line. So moving on. So now talking about multi-collinearity. So again, like I said earlier, it's the assumption that between independent variables, predictive variables and predictive variables. So if you've got, for example, 4 predictive variables, not only do you have that one-to-one relationship that you're looking for to the outcome variable, but you've also got the potential relationship in between each one of those 4 variables. So that's what you're looking at, because you don't want those so closely related to each other that they're not explaining your real outcome. And so if you're looking for that, you'd look for the same way that you would on your scatter plot. You would plot those predictor variables on a scatter plot to each other, and you would see, do they actually have a linear relationship? And if they do have a linear relationship, then they have multi-collinearity. It's when they don't have a relationship that they're not related, and that's actually what you're looking for. So it's kind of a little bit opposite of what you're looking for linearity amongst like on the regression. And then finally, so now I want to show you kind of just an easy way to see multiple models for multiple regression. Because again, on multiple regression, yes, it could only be 2 models, but even if you've got 2, 3, and even 4 or more, it's a lot of relationships to look at. So you need a way of kind of being able to see what all they're doing across the board. So now I'm gonna show you. So this is a table I found looking at some YouTube videos, and some of y'all may see them so well, but I thought this was a really great tool. And you can kind of see that this person had 3 predictor variables. So he at first did, he did one-to-one with the outcome variable. So he used x1 and y1, or x1 and y, x2 and y, x3 and y, and again, y being the outcome variable. Then he moved down and he went x1 and x2 to y, x1 and x3 to y, x2 and x3 to y. Again, he went 2-to-1 on that one. And then finally, for his very last one, since he had 3 total variables, he did x1, x2, and x3 to y. So again, to me, this made a lot of sense to just kind of see, okay, here's all the data for all of it. Which one is the best out of that? And what he found is that his x1 was the best variable that he had that made for the outcome. So that's all I have for y'all today. Again, if you have any questions, feel free to comment in the discussion post. I hope this helps y'all out, and have a good day.